Hey folks, Mr. Green here. I'm taking a sick day because I'm sick and I need the day to recover and I don't want to lose my voice. So what I'm going to try to do here today is to walk you through the remainder of the drawing of our watershed and then also the labeling of it and for your notebook. So in one of the classes, we've already drawn the delta and one we haven't. I believe in Red 3 we've drawn the delta, Red 4 we haven't. So Red 4 should start here, Red 3 you can fast forward a little bit. But basically what you should know is that the river, which we've drawn it coming down here out of the high hills and then combining to form bigger and bigger, a wider and wider channel with more water until finally it reaches the bottom part of the basin and winds its way to the ocean. And at the ocean, it's just going to start dumping sediment that it's carrying. And as it dumps sediment, it's going to then take different channels because it can't go through the place where it dumped all the sediment. And you're going to have a formation of what we call a delta here. The scale of this might be sort of hard to imagine, but I think we've maybe looked at the Nile Delta on Google Earth, and we can in a moment if we haven't already, and you'll see that it's literally hundreds of miles across. And these swatches of dirt that I'm drawing here are being farmed upon, and they're among the most fertile farmland that we can find because of the sediment, which is carrying all these wonderful organics and minerals and just dumping it all here at the end of the river. So, all right, let's go back to my blue color, which I think I was using aqua, and I'll go ahead and fill. These are all channels that are filled with water. I'm not going to try to do the best job ever, but I'll do what I can to fill in some of this with water. And as I do this, and you're catching up with me, I'll go ahead and I'll open up the Google Earth, and we'll look at the Nile Delta, and we'll see how big it really is. And I'm just going to do this until I feel like I don't want to do it anymore. All right, that's probably good enough. All right, let's see if we can find the Nile Delta. We'll go over to Google Earth, run it right out of the browser here, and we'll just go to Cairo. It's in Egypt. That'll get us close. Okay, well, we just zoom right in past it. So here's the Nile. And if you zoom out, you see the Nile Delta. There it is, that big old thing. And you're like, wait, Mr. Green, but we drew it with all these little pieces of sediment. Yeah, well, okay, so fair enough. But if you look in here, each one of those is a field. So that just gives you that idea. And you can see, like, the river or maybe even the canals that have been dug through these farmlands for irrigation are much smaller on the scale because compared to our little brown patches. But just to give you the idea that delta actually can be farmland. Okay, grab your green colored pencil, and we are going to make a little dotted line. Well, I'll try to make a little dotted line here around this section of the watershed. That's the flat bottom land that's going to flood when the river overruns its banks. That's the floodplain. Okay, what we're going to do now is we are going to put some numbers on here, and then we're going to go ahead and we're going to write some notes underneath to label what those are. So I'm going to put, pick up at the top of any one of these little tiny fingers, you can put number 1. Somewhere down further, where some of them have combined, you can put 2. Somewhere in one of the big curves of the river, you can put 3. Somewhere out here on the floodplain, you can put 4. And then down here at the delta, you can put 5. And we're going to describe what those are in just a moment. So let me find a text box, because I'm going to type. So this means I'm going to be able to probably type faster than you can write. So feel free to tell or ask nicely your sub to pause it when you need a minute to catch up. So first thing I'm going to do is I am going to sort of title the thing, which is just with, all right, we have text, we're going to say watershed, I can't read this, / drainage basin, : all the land that drains into one river system. Okay, we might need to make that a little bigger. In fact, let's see if we can make that a little bigger. Or let's go big. That's maybe just a bit too aggressive on that one. Okay, one more time. We'll make it 24. Okay, so this is the same thing we did in the lab. We crumpled up those pieces of paper, we unfolded them, and some places there were places where the paper sloped down, and the water ran down all the sides of those and formed a river system in the bottom and moved its way out towards the edge of the paper, which was the ocean. Okay, now let's go ahead and label some things with numbers. I'm going to make my picture smaller too. All right. 1. This is the 1 that we labeled. That 1 is showing in the high hills, the streams run quickly and straight. All right, that's 1. In the high hills, the streams run quickly and straight. You can ask to pause here if you wish. All right. Say these streams, or another word for them, tributaries. I'm going to put that in caps because I don't have a good way of underlining it. These streams or tributaries combine and make the channel wider as they add more water. All right, these streams or tributaries combine and make the channel wider as they add more water. Okay, once again, pause here if you need to. 3. When the river reaches the floodplain, I'm going to put that in caps too because that's another vocab word, it slows down and begins to, once again, another caps, meander. Meander is the word, if you look it up in the dictionary, it just says to wander aimlessly. And I'll show you the Mississippi in a few minutes and explain a little bit about how and why it meanders and what happens there. Okay, now number 4, we'll say that's the floodplain out there. And I will say the floodplain, once again caps, the floodplain is some of the most fertile farmland because, I'm not sure if this is going to loop on us, I might need to loop this, because the river deposits sediment during flooding. The sediment can be the mineral, but it can also be some of the organic stuff that's in the floodwaters as well. So the floodplain is some of the most fertile farmland because river deposits sediment during flooding. Okay, pause if you need to. And one last thing to add is 5. The river deposits, also deposits sediment at the delta when it reaches the ocean. Okay. So there you have it. When you have all that stuff, your diagram is complete. And on another day, we will cut down into this picture we've made and do a cross-section of it and see what actually happens to the vast majority of the water. The vast majority of the water doesn't end up in the river. It actually soaks into the ground and becomes part of the groundwater table, what's called an aquifer, and we'll make one of those in a future class. Okay, the meandering part. Let's go look at New Orleans, because New Orleans is on the Mississippi Delta. It has a weird shape. Doesn't look like a delta shape. It's all determined by currents and so forth. But if you zoom into New Orleans, you'll find the Mississippi River. If you follow it, you will find that it starts to meander. So look at all these wide bending curves, like here. It's because it's very flat. And what happens is the water on the outside of the curves tends to be moving a little faster. You might have known that because you know how to run around. When you run around a track, you have to run faster around the outside to keep up with the runners running the same speed on the inside. So the fast-moving water around the outside bend chews away at that. And at the inside of the bend, the slow-moving water deposits sediment there, so you have sandbars building out. So the curves get wider and wider because the outside builds out, and the inside builds out when the deposits of sediment happen. And sometimes, when you have something like this, where the curves can get closer and closer together, and when they break through, that cuts off a whole section of the river. Those are called oxbow lakes, and if you go up the Mississippi, you can find them all over the place. Here's one. So this used to, where it says False River, this used to be part of the river, and the Mississippi cut it off, and it got sedimented in, and now New Roads, which used to be on the river, is not on the river anymore. Now, because the Mississippi is a heavily traveled shipping lane, the Army Corps of Engineers tends to try to keep it from changing course too much, so it doesn't cut off like important ports and things like that. And if you go up farther enough, you see this here. The Red River follows down, becomes the Atchafalaya, and exits in the Gulf of Mexico also, but it's a little steeper than the Mississippi. So actually the water, when it busted through, wanted to go this way, and if nothing had been done, eventually the Atchafalaya would have absorbed most of the water from the Mississippi and become the main river. And then New Orleans would have just been sort of like a backwater, got it sedimented in, little trickle of water down there. So the Army Corps engineers built this system of floodgates and such to keep too much water from going down the Atchafalaya and basically making New Orleans a backwater. So it's just another interesting way that we try to control the Mississippi River. Some more down here. Anyhow, that's the end of this video, and I will see you next class.